Okay, so we're going to look at the idea of mole calculations over the next two videos. We're mainly looking at this first one, just as what even is a mole. So a lot of people do mole calculations, they maybe learn the steps, you do this and you do that, and so on, but often we don't really know what even is a mole, which is probably quite an important thing, otherwise you don't really feel like you're probably learning that much. So we need so what is a mole? Okay, so basically, very simply, it's not too hard to actually grasp what a mole is. A mole is this many of something. That's it. It's just this many of something. So this many chlorine atoms, this many titanium atoms, this many sodium atoms. Okay, so it's just let's forget about all these decimal places. We'll round it all the way up to 6 times 10 to the 23. Okay, so 6 and then 23 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. Okay, so 20. That many sodium atoms. That's what a mole of sodium is. That many chlorine atoms. That many titanium atoms. That's what a mole is. So why did he pick this particular number? This is Avogadro, this guy here. He picked this number to be a mole of something. And the reason why I picked that number is it just so happens that when you have that many of a particular element, it just so happens that the weight of a mole, or the mass I should say, of the mole ends up being what the atomic mass is. So if we have a look up here, well, let's take this one. On your periodic table, the mass number will be 48. Okay, so, and if I get that many of the titanium atoms, it just so happens that a mole of that many titanium atoms weighs 48 grams. So, and it just so happens if I took 6 times 10 to the 23 sodium atoms, it would weigh 23 grams. So that's the reason why he picked this number. Okay, this number was worked out to be the number of atoms that would make it such that many would weigh its atomic mass. So what I'm going to do is I'm going to get you to pause this video now and have a think of what would the mass of a mole of protons, just protons, on its own weigh. So pause the video and have a think, and you should have come up with 1 gram. Same with the neutrons as well, also 1 gram. And the reason being is because sodium is 23 grams because it's got 20 inside each one of them. There are 23 protons / neutrons, otherwise known as nucleons. A nucleon is either a proton or a neutron. So 23 nucleons, and each one, a mole of which would be 1 gram, because a mole of 23 lots of them weighs 23 grams. Okay, so that's the end of this video. I will make a second video about how to do some of the calculations.